In this video, I'm going to show you how to find all the readings on these meters. This is a voltage source of 22 volts. That's an ammeter, so it's going to register the current flowing through there. These are voltmeters, and they measure the voltage across, the voltage change from here to here. Okay. Now, the first thing you want to do, this is not a circuit I know how to solve. It's not series, it's not parallel. So I have to reduce the circuit until it looks like something that I can solve. So the first thing I'll do is since current here goes through this one, then this one, it's definitely series, right? This guy doesn't joke very much, right? He's very series, right? So an 8 and a 7 in series is 15 ohms, right? And now if you look, the 15, if we replace that with one resistor, and the 11, well, this end's connected to this end's to this end, that's parallel. Okay, so this thing here, okay, has a resistance of, in parallel, the formula is 11 to the minus 1 plus 15 to the minus 1, all of that to the minus 1, right? It really looks like this. It's 1 over 11 plus 1 over 15. But this is the way I like to type it into my calculator. So let's do that. Let's see what this looks like. Okay, let's turn the calculator on, and 11 to the minus 1 plus 15 to the minus 1 to the minus 1. And I'm going to store that in A. And there it is, 6.346 ohms, and I've stored that in A. This is key. This little keystroke right here, I don't know if you can see that, right, is you go storage, and on your calculator you'll have to say alpha A, right? But here I can just go storage A, and my calculator's better set up to do that. You want to do that because you don't want to write down all of these digits. So it's easier to store them in the calculator than to write down, 17 or something like that. Okay, so there we've got that. Now this is a circuit I can solve. This is a 5, a 6.346, and a 9, and they are in series. Okay, so I'm going to solve this thing, right? And I'll show you what I do. Okay, so here's this current, right? Here, of course, it gets a little complicated there, right? And then there it is, right? But for the rest of the circuit, it doesn't care. That's a 6.346 ohm resistor, even though it's made up of all those resistors, right? So the current, that one current, is V over R, right? So it's 22 divided by 5 plus 6.346 plus 9. Now, watch what I do on the calculator. I don't have to type all that in because I've stored that in A. Watch. There's A. If I type A, it replaces it with that value, right? So I go 22 divided by left parenthesis 5 plus alpha A plus 9. And it types all of that A in there. By the way, I'm going to store that. I hit the storage button, and then you have to go alpha B. I just say B because it's a TI-86, right? And this current is 1.081, okay, amps. Ta-da. Okay. Now I can pick off these voltages here, right? Remember, this is a series circuit, okay? So this voltage here, V1, is IR, right? And that's going to be 1.081 times 5, okay? Let's do that. Let's see. Actually, I can just go times 5, because there's that current, right? And I'm going to multiply the answer by 5. And this is 5.406. Okay, and now let's pick this guy off here. V here equals V2 is IR, right? And it's that same current. This same current goes through this, right? Okay, so that's going to be 1.081 times 9 in this case, right? So where is that? Alpha B? There it is. See how I stored that in the calculator? There it is, 1.0. Then I just go times 9, and I get 9.73 volts. Now I know I'm just exaggerating the sig figs. I know we have like one sig fig here, but I'm going to answer these, to 3 or 4 or something like that, right? Now if you look at the bottom of the page here, right, you can see all these answers. This is an Excel spreadsheet I pasted in there. Excel spreadsheets are also wonderful for doing this. Now, before we move on, I've got to find the voltage across this reduced part. This is the most important part of this, right? Is I'm going to find that voltage across the reduced part. Okay? So the voltage from dot to dot is going to be IR, right? And that's going to be 1.081 amps times this reduced resistance of this, that the circuit sees from there to there, is 6.346. Okay? Now, somewhat surprisingly, that's alpha B and then alpha A, right? Somewhat surprisingly, that's B times A, right? So I can go alpha B times alpha A, right? And then I'm actually going to store that in C just for fun. Okay? So that is 6.862. Ta-da. That is the voltage from here to here that's pushing. We can now ignore the entire rest of the circuit. It's like it doesn't exist. We can pretend that there's 6.862 volts of potential pushing current through this circuit, and we can ignore the rest. Okay? So let's draw what we have now. Now the circuit looks like this. $11 ohms, right? That's this guy, right? And then it's there we go. Okay, and then this is 8 ohms and 7 ohms. Okay, this battery here is a 6.862 volt battery, right? Which is, by the way, what did I store that in? I stored this in C, the variable C. So whenever I need that on my calculator, I can just simply type a C, alpha C, there it is, all of its precision. Okay, now, if you look at the circuit there, there's an ammeter right here. Okay, so let's find that current, that's easy. Okay, A2 is just going to be V over R. The voltage is this voltage, the 6.862. Right, that's my reduced voltage, divided by 11. Okay, so that, the answer on my calculator divided by 11 is 0.6238 amps. Okay, and then let's look at the circuit there. There's a voltmeter across this guy, right? That's V3, like that, right? So how do we do that? Well, it's a two-step thing, right? Okay, what I have to do is I have to find this current. I'll call it I through the 8 and the 7, right? Okay. Well, that's easy too, because it's the 8 and the 7 are connected directly to the 6.862, right? So that's going to be V divided by R, right? That's going to be 6.862 volts divided by 8 plus 7. Yeah? Okay. And then that equals, let's do that. So let's see, alpha C, there's my potential, right? Do you see that? Okay. So alpha C divided by parentheses, 8 plus 7. I could just type 15, couldn't I? Right, and I'm going to store that in D. Not that I have to, but I'm just doing it because, you know, what the heck. Right? So that's 0.4575 amps, right? And that's not one of the answers, but to get this voltage, to get that voltage right there, I are going to multiply that by the resistance, right? So V3 is IR, okay, is that current there, 0.4575 amps, right, times, well, in this case, 8 ohms, right? So let's do that. I'm just going to multiply what's on my calculator times 8. And I get 3.660 roughly, right, volts. Okay. So again, the steps for this are pretty basic. You reduce it until you can solve it. Solve all the parts. Then find the voltage across the part that's still reduced. Redraw the reduced part with that voltage across it. Solve it, and you're done. Sometimes you're done. Sometimes this is like part of these, one of these is a reduced resistor. Anyway, I hope that helps.